Okay, so the last of the people in the waiting room have now appeared to be joined in, according to my monitor here. So let's get underway. Vectors session 3. I think gradually all of you are now getting used to the idea of vectors and the geometrical representation of vectors, which is what we have more or less used till now as the method of vector analysis or vector operations. Okay. However, starting today, we will look at another optional method of vector analysis, which will be through the component algebra. So as always, let's start with a quick recap of the important things that we learned last time. So the most important thing that we understood last time was actually we did a lot of things like the redoing of the vector triangle law and all that. But most importantly, towards the end, when we reached, we saw in the triangle law formula that we have the resultant of A plus B is equal to that formula. Now we saw how to deal with the situation when theta becomes an obtuse angle. So A square plus B square plus 2AB cos theta and tan alpha is equal to B sin theta upon A plus B cos theta. So these formulae have become very much part of your system by now, and they are very natural for you to apply. But also they are natural for you to apply in the condition when theta being obtuse. Okay. So we saw that whenever theta is obtuse, for example, theta might be 135 degrees or 127 degrees or 153 degrees or things like this. Sorry, 143 degrees would be a more useful way. 153 would be something you would require, again, a scientific calculator to solve. So 143 degrees, these kind of values. So what we saw is when that happens, we use the formula for second quadrant. For quadrant 2, we use the formula that cos of 180 degrees minus theta is equal to minus cos theta. Whereas sine of 180 minus theta is equal to sine theta. Okay. So in other words, for example, if we want to find out cos of 143 degrees, we will see that it is minus of cos 180 minus 27 degrees, sorry, minus 37 degrees, minus 37 degrees. So we will see now by this formula, it will become minus cos 37 degrees, and therefore it will become minus of 4 by 5, which you might be familiar by now, solving these type of questions. So this was one very important aspect. But more important from this is how we got this formula, how we got the formula of the second quadrant from, how we got sine theta and cos theta. So that aspect of projection. So I'm quickly going to go through the concept of projection here. So if these were our x and y axis, we saw that in terms of projection, the way we define angle is, it is nothing but the angle with respect to the positive x-axis at which a particular line has been rotated, and it's a standardized line. So we take a unit length line. So we take something of unit length and we rotate it from the x-axis through an anti-clockwise angle of theta. So for example, theta here could be that 143 degrees. So if it is like this, then we want to see that in this diagram now, what is my sine theta and what is my cos theta. So we drop the perpendicular on the x-axis. So you can see that this projection here, this one, it becomes a negative x projection, whereas we drop the perpendicular on the y-axis, and this projection we saw last time, this is a positive y. So we can see that the value of x is nothing but cos theta, and it is in fact a negative quantity. It is negative of mod of x. And further, what we saw, what was mod of x, that we saw from this triangle. So in this triangle, this angle here, if we label this as alpha, it is nothing but minus cos alpha. So that is how we get the formula, that it is minus cos of 180 minus theta. So this is a simple way to understand why the value of cos theta ultimately becomes minus of cos 180 minus theta, which is why cos of 143 degrees in fact becomes minus 4/5. Whereas if you look at y over here, it is actually by definition sine theta, but you can see it is on the positive side, so it is plus of mod y. And again, in that triangle, you can see here that this side, the perpendicular side, this one would be of mod y. Okay? So it would be positive of mod y, which is positive of sine alpha. So that's why it becomes positive of sine 180 minus theta. So that is how we get the relation, that this formula, that sine theta becomes positive of sine 180 minus theta. So this is something which you need to absolutely internalize. So sine 143, for example, will become positive of sine 37, which you all know is positive of 3/5. Right. So this is about the concept of yes, I have seen a couple of your doubts. I will be answering about that in just a moment. Okay, but just so that I don't lose train of thought, I'm just continuing with this for a moment. So we saw this is how we get the formula for the second quadrant. Okay, and now in a very similar manner, we get the formula for tan theta, which becomes sine upon cos. So next time, just going to quickly go through some of the questions that you people have put through. Yeah, doubts in question 13 and 15. I will be coming to questions from the worksheet very soon. I'll explain the carom board question also again for those of you who require that. Okay. Also, I just saw a question from somebody which was about what happens when, can we add vectors if they are of different quantities, different physical quantities? Okay. I just saw that particular question from one of you people, that can we add vectors if they are of different physical quantities? Like, for example, can we add a force vector with a displacement vector? The answer to that is no. Okay. Addition in that sense is just like the general principle of addition for all physical quantities, that vector addition can only be done for two quantities which are of same dimension. Okay. Or vector subtraction, for that matter, also can only be done for two quantities which are of the same physical dimension. So we can add or subtract to displacements, we can add or subtract to forces, but we cannot add or subtract a displacement with a force or a velocity with a acceleration or something like that. And that is something important. Okay. Now, for multiplication is a different thing. In fact, Sarvesh, to answer your question, yeah, you cannot see my white screen. It's just coming on board again. Don't worry. But I just want to speak about a general few things first. So yeah, about multiplication, in fact, we will see that we have not done vector multiplication yet. What we have done is multiplication of a vector with a scalar quantity. And to that end, we saw that if we say that a certain vector is, let's say, 5 times another vector, then its magnitude is 5 times, but its direction is same. If we say it is minus 2 times a certain vector, then its magnitude is 2 times, but the direction is opposite. So things like that are what we have seen till now. Now, there is actually no such thing as vector multiplication, okay, which we are going to come to very soon. There are certain things which are called vector products. And to that end, we will see that there are 2 types of vector products. And we are going to learn that probably in our 4th lecture, which is going to be next time. So as of vector products, we haven't learned anything as yet. Okay? We'll see that there are, if you look in your module, there are 2 things ahead, which are the scalar product and the vector product. And we'll discuss about that. Yes, and I will answer your question about axial vectors also. But first of all, I would like all of you to work out a quick question for me, which is based on just this concept over here. Okay, so just try out the following question. Okay, while my whiteboard is coming on board again, just try out this question, and some more people are also seem to be rejoining. We seem to be having some connectivity issues. So I will put up the question on the whiteboard the moment it comes up. But in the meantime, those of you are following this lecture, just try out this question. So note down, okay, magnitude mod A, magnitude of A, that is mod A, is equal to 1. Okay, mod A is equal to 1, and mod B is equal to 2 units. Okay, so A is a vector of magnitude 1 unit and B is a vector of magnitude 2 units. Okay, and now listen carefully. If C, okay, if vector C is equal to the resultant of A and B, if vector C is the resultant of A and B, just write this down. So if the vector C is the resultant of A and B, and C is perpendicular to A, okay, and C is perpendicular to A. Okay. Then find out magnitude of C. So find out the magnitude of the vector C. Okay. And also find out, so find the magnitude of C and also find out the angle between A and B. Okay. So people, I want you people to try out this question and send me the answers quickly. Alright. So this becomes the solution of this particular question. Right. Just check if there. Yeah. So this becomes the solution. So why I did by the geometrical method first? Because I understood on looking at the question that geometrical method is going to be easy. Why? Because I picked up this thing that C is perpendicular to E. That means I'm dealing with a right angle triangle. Dealing with a right angle triangle, I don't need to use the fancy formula of triangle and all that. I can just make the diagram and that should be the easiest. Okay. However, just for the sake of practice, let us also understand how to solve this by the formula method. Formula method. So in the formula method, see what is given to me. E is given as 1. B's magnitude is given as 2. C's magnitude is unknown. Theta is unknown. Okay. But alpha is given to me as 90 degrees. So the things that are given to me, notice very interesting, are alpha, A and B. So if I have to think in terms of formula, I have to think which formula involves these three things. If I use the magnitude formula for C, I have theta which is an unknown, so I don't know that. So I can see that I have to use the relation of alpha with respect to magnitude of A and magnitude of B. That will be the convenient thing to do. So that is what I do next. So I use that formula that tan alpha is equal to B sine theta upon A plus B cos theta. Now I substitute the values which are given. So just on the top of the board, you can see what all values are given. I've got alpha is 90 degrees. So tan 90 degrees has to be equal to B, which is 2, into cos theta, which is unknown, divided by A, which is 1, plus 2 sine theta. Right, I get this. Now this is where your maths knowledge becomes very important. What is tan 90? It is an undefined quantity. And what is on the right hand side? It is 2 cos theta upon 1 plus 2 sine theta. So if it is an undefined quantity or tending to infinity, what does that mean? That the denominator must be 0. So 1 plus 2 sine theta must be 0. Okay. So that tells me here that sine theta must be minus half. Oh, sorry, not sine theta, cos theta. Please make a correction, guys. This has got interchanged for some reason. So this is actually cos theta. So cos theta should be minus half. So as you can see from above, from the formula, we have B cos theta in the denominator. So, and we have B sine theta in the numerator. So we've got this. So cos theta is minus half is now what we have to solve for. And that is where again your knowledge of trigonometry comes in. So cos theta is minus half. So the moment you know cos theta is minus half, I know that theta is in which quadrant? Theta is an obtuse angle because cos is negative. Okay. So that means that we can write cos theta as minus of cos 180 minus theta, and that should be equal to minus half. Okay. So substitute this value here. So what does that tell me? That tells me cos of 180 minus theta is equal to half. So that tells me the angle on which I'm applying the cos, that is 180 minus theta, that angle is how much? That is 60 degrees. Okay. Or if you like, you can write this angle as alpha. So minus cos alpha is equal to minus half. That means cos alpha is how much? Half. So that means alpha is how much? It is 60 degrees, which now really shows you that theta is 120 degrees. So if you want a very detailed formula-based, mathematical approach to how to solve this problem, then this is the one for you. But having said that, this is not the really suitable way of solving the problem. The more suitable way of solving this problem would have been what we had done in the first method, which is we drew the right angle triangle and solved it. Okay. So anyway, just take a look at this method and I'll scroll it down also, but first I'll absorb the first few steps over here. Right, Piyush, so I think you were pointing out that fact only. The actual formula is b sine theta upon a plus b cos theta. By mistake interchange sine and cos, but with that correction in place now, hope it is clear. Yes, so to answer your question, Tarisha, in method 2, what I am doing is I am using the formula based method. So in the formula based method, I have to first of all understand what all is given in the question and what all is unknown. So the given quantities are mod A, mod B and alpha. ठीक है, so मैं कौन सा formula use कर सकता हूँ? I cannot directly use the a plus b वाला formula because in that theta is unknown, right? Rather, I can use the tan alpha formula because in that alpha is also known, a is also known, b is also known, and from that I can find out theta. So that is what we are doing in the second method, Tarisha. So I'm making use of this formula, the relation between this one, the relation between alpha with respect to a and b, and that if you look in our formula base, this was tan alpha is equal to b sine theta upon a plus b cos theta. Now relate this with the information given. तो मुझे क्या दिया हुआ है that the vector c is perpendicular to the vector a. That means the angle alpha is 90 degrees. So left hand side becomes tan 90. What else is given? The magnitudes of a and b. So substitute the magnitudes of a and b. So what I'm left with in the equation that I got is only one unknown quantity, which is theta. Okay, there is sin theta and there is cos theta, but there's only one unknown step, which is okay. Now where it gets a little complicated is how we use the value of tan 90. Tan 90 मुझे पता है कितना होता है. Tan 90 is actually an undefined quantity. It's undefined. So undefined because what? It is a division by 0. Okay, like this. Or another way you can understand is tan 90 is equal to sin 90 divided by cos 90. Now you know by definition sin 90 is what? Unity. But cos 90 is how much? 0. So tan 90, why it is undefined? Because it has a 0 in the denominator. So this is the step that we are using. So if tan 90 is undefined, that means when we are expressing it as a as a ratio, in that ratio the denominator should be how much? It should be 0. Okay, so this is the step. The denominator should be equal to 0. Okay, good. So this is a little trick which is very important in both your trigonometry in mathematics as well as in this kind of application in physics, that whenever we are dealing with a situation where we are having tan 90 equal to something, on the other side I have some equation, tan 90 is equal to some numerator divided by denominator, so that denominator must be 0. So this is a trick you remember. Okay? So whenever we are dealing with an equation where tan 90 is equal to some fraction on the other side or some ratio on the other side, so on the other side the ratio's denominator must be, by definition, must be 0. Okay? So that is the important. Okay. Now what we will do next today is we will continue ahead with trigonometry in 4 quadrants. Okay. So I will discuss some of the questions of the worksheet, but I might not get time to do all of them today because there are a few theory things I want to do first. So in that case, we will carry forward the discussion of the worksheet, the remaining part, to the next lecture, don't worry. So I will discuss all the worksheet problems. That is not the issue here. But the thing is the flow of the lecture today, because of where we are in the topic right now, it is more important that we learn the things ahead before we come back to the difficulties you're having in the worksheet. Okay? So continuing ahead now, we will also understand projections in 3rd and 4th quadrant, and thereby we will be finishing the ASTC rule formula. We only saw for 2nd quadrant last time. Now we'll be finishing the one for all the quadrants. Okay. So let us look at quadrant 3 first, because we already discussed quadrant 1 and 2. So when we are talking, we mean the angle we are talking about is greater than 180 and less than equal to 270. That's the situation we're looking at. So this is the origin in our system. This is our positive x-axis. This is our positive y-axis. Now we are looking at quadrant 3. So theta has to be more than 180 because it has to cross that line, and it has to be less than equal to 270 degrees. So we are talking about rotating our so-called unit rod in this manner. It is somewhere over here. Okay. Now see, one objection you can always have over here कि मैंने theta को ऐसा लिया है अगर कि ये angle 180 से ज़्यादा है. Why don't I take theta the other way? Why don't I take it as clockwise and say that it's an obtuse angle instead of being in the third quadrant? Why I have to catch my nose the other way? It's like saying this. So for example, if theta here is, let us say, for example, let us say theta is 180 plus 45, so that is 225 degrees. That is 180 degrees plus 45 degrees. Okay. So why I cannot say theta is this one? In which case it would be 135. The question is very valid. I can say it is this also. But if I say it is this, I should say with what? Minus sign, because I am already using the convention. So remember that we are using the convention that positive theta is which sense? It is anti-clockwise. So that is why I am forced that if I am writing theta over here as a positive quantity, if I am writing it as positive of 225, I have to go in the anti-clockwise direction. I can write it as 135 also, but then I should write it as minus of 135. I cannot write it as positive of 135. So anti-clockwise is positive, whereas negative is clockwise. So I am forced by that convention that I have to go in this manner. Okay. And now this is the rod of unit length. So now let us drop perpendiculars from this rod and let us understand how the projections are falling. So as it's very clear to see, the projection on the x-axis is negative, and now the projection on the y-axis is also negative. So you can see what is happening in our third quadrant is both the projections in Q3, okay, x and y, both are negative. Okay. Both projections are on the negative side. So what does that mean? Cos theta is a negative quantity. Sin theta is also a negative quantity, which is why the ratio of sin and cos becomes positive. Because remember, tan is just the ratio of sin and cos. So which one is positive in the third quadrant? It is tan. Okay, so hence we have the ESPC rule. This is T. A is all for first quadrant, S is sin for second quadrant, P is tan for third quadrant. So this is what happens. Okay, so I'll just minimize this a little bit for you to first absorb this information. Then we will see how to develop the formula for the third quadrant, just like we've got the formula for the second quadrant also. Okay. So the moment your standard rod is rotated by this kind of an angle, that it's now lying in the third quadrant, you can see the shadow it's casting on the x-axis, that is your x projection, is also negative. The shadow it's casting on the y-axis, which is the y projection, is also negative. And remember, by definition, the projection on the x-axis is nothing but cos theta when we are taking a rod of unit length. Okay. And y is sin theta, and tan, y by x becomes tan theta. So now in this quadrant, you can see what is happening in third quadrant. These two are negative, so obviously this becomes positive. So that is why cos is negative, sin is negative, whereas tan is positive, and that's why it's labeled with the symbol T in the ASTC. Okay. So I'm sure this is pretty clear. I'll just check your messages once again. Okay. So now it is about the value. Okay. So how to find the value of sin theta and cos theta? Or you can say the formula for sin theta, cos theta, tan theta in quadrant 3. So for that, let us for the moment now concentrate just on where our rod is. So So our rod is here. And this total angle, this one, this angle is my theta. So in this diagram, you can see this total angle up to here. Okay, starting from here up to here, this angle is theta. Okay. So next, what I can do is when I'm constructing my right angle triangle, okay, here, so I'm dropping this perpendicular from here, and I'm dropping this perpendicular from here, and I'm constructing this right angle triangle. So I can see this angle. I can label that as alpha, and alpha actually becomes how much? It becomes theta minus 180. Are you able to understand this? Why alpha is becoming this? Or in other words, theta is equal to 180 plus alpha. In the second quadrant, theta was 180 minus alpha. In the third quadrant, theta is becoming 180 plus alpha. This angle from here to here. This angle is my alpha, and that is becoming 180 minus alpha. 180 theta minus 180. Okay. So for example, for theta equal to 225 degrees, my alpha will become how much? It will become 45 degrees, because you know that 225 is actually 180 plus something, and that something is what it is, 45. Okay. So first, let's make sure we understand this. Okay. Then let us come back to this triangle. Okay. So I'm redrawing this triangle like I had done before. Okay. So in this triangle, this side as a projection, this side should be x, which is, remember, on the negative side, and this side should be y, which is also on the negative side. Okay. So now, as far as just this triangle alone is concerned, just as a right angle triangle, if I redraw this triangle, तो ये वाला साइड लेंथ कितना हो जाएगा? इट विल बी mod x. ये वाला साइड लेंथ कितना हो जाएगा? इट विल बी mod y. ये वाला साइड कितना है? यूनिटी है, because remember the length of our triangle after all, I mean the length of our rod was unity, and this angle here is how much? It is alpha, and this angle is 90 degrees. Okay, so applying trigonometry for that triangle, what we are getting? We are getting cos alpha is mod x by L, sin alpha is equal to mod y by L. Okay. And we of course understand that L is unity in both of these. So in other words, from this set of formulae, what we are getting as mod x, we are getting it as cos alpha, and what we are getting as mod y, we are getting as sin alpha. Now you go back to your earlier projection diagram, and you can understand the x का mod तो मिल गया, but what about the sign of x? It is negative. What about the sign of y? That is also negative. So what should my x become? My x should become minus cos alpha. And what should my y become? It should be minus of mod y, so it should become minus sin alpha. Okay. And that is nothing but cos theta. Because remember, trigonometrically, we have defined the projection on the x-axis only as cos theta, and we have defined the projection on the y-axis as sin theta. Our definition of sin theta and cos theta in terms of four quadrants is no longer perpendicular upon hypotenuse and base upon hypotenuse. It is nothing but the x projection and the y projection when the length of the rod is unity. So from that, what is the formula we are getting? We are getting the formula that cos theta is minus of cos theta minus 180 degrees, because alpha was that, and sin theta is also minus of sin theta minus 180 degrees. So these become our formulae for the second quadrant. Okay, so I'm just going to first of all box these formulae, and then just take you through a quick refresher of 1 minute break. Okay, and I will reboot my router again. Okay, just take a 1 minute break because the whiteboard is actually frozen. It's not. I'm not able to minimize it. Okay, just take a 1 or 2 minute break. I'll be back. So just take a look at what we've done for the calculation over here. So my angle theta, I have subtracted 180 degrees from it. So I'm getting that angle 180. So for example, if my theta were 225 degrees, if you subtract 180 from it, you'll get 45, which is that red colored angle of alpha, which I've shown in the diagram. So now you just concentrate on that right angle triangle, whose sides are mod x and mod y, and whose hypotenuse is L, which is unity. And you apply trigonometry for a triangle on it. So cos alpha is mod x upon L and sin alpha is mod y upon L. So from that you're getting the value of mod x as cos alpha and mod y as sin alpha again. But now go back to your projection diagram and you can see that okay, mod x to mil gaya mujhe, but x kaisa hai? X is a negative quantity because it's on the negative side, and similarly y is what? It's a negative quantity. That means x with algebraic sign when it comes, it should come with a negative sign. And similarly, y with algebraic sign when it comes, it should come with a negative sign. So that is why your mod x is cos alpha, means x becomes minus cos alpha. Mod y is sin alpha, means y becomes minus sin alpha. And then finally, remember what is x by definition in trigonometry now. X is nothing but the projection on the x-axis. So it is defined by cos alpha. Now, whenever we take L, the length of the rod is unity. That means by definition, the x projection is cos theta. And by definition, the y projection is sin theta. So that is how these two steps over here, I'm replacing x with cos theta, I'm replacing y with sin theta, and finally I'm getting cos theta is minus cos alpha, sin theta is minus cos alpha. And remember what is alpha? Alpha is this thing. So this is what I'm doing. So we are substituting alpha as 180 minus theta. Okay. And I'm substituting x as cos theta and y as sin theta. So that is how these two formulae have come. So just as for the second quadrant, we had the formula that cos theta is minus of cos 180 minus theta, and sin theta is plus of sin 180 minus theta. For quadrant 3, what becomes my formula? It becomes that cos theta is minus cos theta minus 180, and sin theta is minus sin theta minus 180. All right. So people hope this is clear. Okay, now let's quickly work out some examples using this formula. So for example, Asha, by the way, what about tan theta? Tan theta will just become ratio. So tan theta is the ratio of sin theta upon cos theta. So sin theta becomes minus of sin 180 minus theta. Cos theta becomes minus of cos. So the minus sign cancels out and we just have positive or just tan of 180 minus. So this becomes the fourth and final formula of theta minus 180. Sorry. Yes. Minus sin theta minus. Alright. So let's work out an example. So for example, we want to find sine of let us say 240 degrees, cos of 240 degrees, and tan of 240 degrees. Okay. Just apply this formula quickly and work it out. Tell me how much you'll be getting here. So which is the formula we'll use? We'll use the formula that sine theta is minus of sine theta minus 180 degrees. Okay. Cos theta is minus of cos theta minus 180. And tan theta is positive of tan theta minus 1. Yeah, so let me check your answers quickly. Yes, Saurabh, Aditya. Yeah, Aditya, tan will be with positive. Yashmit, your answer is correct. Yeah, Sarvesh, to answer your question, how x is cos theta, that is like from previous lecture, if you see towards the end, when we discussed the definition of sin theta and cos theta in terms of projection, you will get it again. Okay? So the projection of the rod of unit length on the x-axis by definition now becomes cos theta, and the projection of the rod on the y-axis becomes by definition sin theta. Okay, so that is where that is coming from. So here, as you can see, sine of 240 degrees just a moment, guys. We're getting some lag. Right. So sine of 240 should become minus of sine 240 minus 180. So that is minus of sine 60. So that is minus root 3 by 2. So this is my sine 240. Similarly, cos of 240 according to the formula should become minus of cos 240 minus 180. So it should become minus cos 60. It should become minus half. Okay. So this is your sine, this is your cos. And tan just divide the two, so it's root 3 as you see. So this is how we calculate the this thing, what we call the sine and cos values or trigonometric functions of sine and cos when our angle is in the third quadrant. Okay, people, so hope this is clear to you. Okay, now tan you can just get by dividing the two. Therefore, it will become equal to tan 60, not with a minus sign, but so it will become. So these are the values. Right. So I'm assuming that this is clear, and with more practice, you will get used to these formulas. I'll list out the final formula in the end also for you. Okay, now we come to quadrant 4. Okay. So theta is now greater than 270, but less than 360 degrees. Okay. For example, we could have theta equal to 300 degrees or 315 degrees, like this. So now my situation is looking like this. So as you actually already know from the ASTC rule, this time it is cos theta which will be positive and everything else will be negative. So if I'm in the fourth quadrant, that means this kind of thing is theta. Okay. So you can see the projections, the X projection is positive and the Y projection is negative. So this is positive. So that means what is happening? Cos theta is positive. Because X projection is nothing but cos theta. And this is negative. So what that is telling us? That sin theta is negative. And therefore tan theta becomes automatically negative because it's the ratio of sin and cos. Or it is the ratio of y by x. So x being positive and y being negative. So that's why we understand that in Q3, or sorry, on Q4, it is C. All sin, tan, cos. So it is cos which is positive, the other two are negative. Okay. Now about the formula, you will see it's equally easy. Okay, so just take a minute to absorb this first. Right, so hope thus far this is clear. Yeah, beta about the random angles like 311 or 327. It is just like how you would calculate sine or cos of 20 degrees or 15 degrees. You have to use a table. You don't know the values directly. You have to use the sine cos table or you have to use a scientific calculator. Again, if you refer to the last part of my previous lecture, lecture 2, I have shown you how to use a scientific calculator using an Android phone, a real calculator, or any one of those you can download. But the thing is, in your studies, I mean, in your questions of JEE level over here or even 12th level, 11th, 12th level, you will not get values which are random unless the table is given to you in the exam. Okay, so don't worry about that immediately. But yes, there is a general method how to calculate sine of 15 or sine of 5 degrees or sine of 27 degrees or anything like that, or sine of 52 degrees, 57 degrees, anything random like that. And that is by the table or by the scientific calculator method. Okay. All right, now let's see the formula. So the formula is again the very similar kind of process as we have discussed earlier. So we'll just concentrate here on the fourth quadrant where our rod or whatever it is there. Okay. So it's here. So now again you can see. Okay. Now this angle is theta. This whole angle from here to here, this is theta. So when I drop the perpendicular and all, I'm going to get this kind of a triangle. The triangle is in quadrant 4. This triangle. So for this triangle, I can take this angle now as alpha. And that will make life very convenient when I take that angle as alpha. So first of all, you can see that alpha is equal to how much? It is 360 degrees minus theta. So for example, if theta was, let's say, 330 degrees, that means alpha is 30 degrees. Yeah. Secondly, you can see that this projection here is my x, which is positive, and this projection here is my y, which is negative. So now let us concentrate on this right angle triangle and let's understand the geometry of this one. So again, you will see that you will get similar related kind of formula like we've been doing till now. So if you just take aside that right angle triangle, so the length of this side as a magnitude is mod x, the length of this side as a magnitude is mod y, and this is unit length, and this time this angle is alpha. So again, mod x divided by L is the same formula. They keep repeating, as you can see. Mod y by L is equal to sine alpha, and L is unity. So you will get mod x as cos alpha, and x is positive. So x is becoming how much? Positive of cos alpha. And by definition, x is what? It is cos theta. So cos theta becomes positive of cos alpha. Similarly, you will get mod y, because L is unity, as sine alpha. Now this time y is what kind of quantity? It's a negative quantity. So it is minus of sine alpha with sine. And y is defined as what? It is defined as sine theta. So sine theta becomes minus of sine alpha. So this formula and this formula are now giving us a method of calculating the value, and generalizing those formula, we can see we will get this, that sine of theta is minus of sine (360° minus theta). So that is what alpha was. And cos of theta is positive of cos 360° minus theta. And therefore tan theta, which is just the ratio of these, is negative of tan 360 minus theta. So these become the formulae for quadrant 4. Okay. I'm just minimizing this for you to understand this first. Okay. So it's absolutely the same steps that we've done for quadrant 2 and quadrant 3, but just that now we are expressing that angle alpha. In quadrant 2, angle alpha was expressed as 180 minus theta. In quadrant 3, it became theta minus 180. And now in quadrant 4, it became 360 minus theta. Okay, Tanish, you might be having connectivity issues if the video is not clear in between or something, but don't worry, I'm doing the recording over here, so you will, whatever portion was unclear to you because of connectivity issues, you'll be able to see later. Right, so hope the whiteboard is clear now. You are able to see the whiteboard, right, Tanish? Okay. Okay, so this actually establishes how to calculate sine theta, cos theta, tan theta for all angles. Actually, Tanish, you're not able to see the whiteboard. I think you will have to, you will have to basically reconnect once, because your connectivity must have gone off. You can try, logging off from the internet and then connecting back on. So whatever data or Wi-Fi you're on, just disconnect and connect once, you should be able to get it. I was having connectivity issues a little while back, but now my connection seems to be all right. Okay, so must be your end. Okay, so I'm just scrolling down to the lower part where we have the final formula, and then we'll work out a question. Okay, so in fact, now just calculate, take theta as 315 degrees, okay, and tell me how much is sine theta, cos theta, and tan theta. So once you've written down this formula, we will just try it out for this. Yes, Dhruv, that is correct. Sine is correct. Cos is also correct for you. Yes, Tarisha, 45 is the value you'll use. Now you have to use the formula. So sine theta will become something in terms of sine 45. Similarly, cos theta will become something in terms of, yes, and Dhruv, your answers are correct, all three. Yasmin, yours are also correct. Aditya, correct. Good, Tanish, your connection is clear now, good to know. Kevin, yours is also correct. Kevin, okay. Good. Yasmith, correct. Samarth, correct. Mehak, correct. Piyush, you are also correct. Yes, so now you have to give the values numerically. Okay, in terms of 45 you said, but you have to give the answers. Okay, all right, good. So it's just, now you can see it's just a matter of application of formula. as we are doing. So therefore, for example, sine of what was it, 315 degrees. So according to the formula of Q4, which is just above this over here, it is sine is what, negative in the fourth quadrant. So it is minus of sine 360 degrees minus 315. So it is minus of sine 45 degrees. So it is minus 1 by root. Similarly, cos of 315, when you work out by the same steps now, you will see it will actually become plus of cos 45. So that will be plus of 1 by root. Whereas tan of 315 will again become minus of tan 45. So it will become minus 1. So sine is minus 1 by root 2, cos is plus 1 by root 2, and tan is minus 1. So these are our final answers. All right, so just complete this question and we will continue ahead. Just a moment. Yes, I will be sending more worksheets, Tarish, but we have to discuss the second worksheet also, which is part of some things we'll be doing today. All right, so this is about 4 quadrants. Okay. Now, next thing we will see through this is vectors represented in what is called component form. So till now, we have seen only one way of representing vectors, which is the geometrical form. But now we will learn how to represent a vector. So suppose we have a vector A like this, which till now we have just been representing by an arrow and by giving some properties of the arrow, that okay, its length is so much and its direction is so much. But now we will learn to represent that in terms of a coordinate frame, and it will become what we call components. So when we say in component notation, what we mean is it is with respect to a rectangular coordinate frame or with respect to an XY system. Okay, so in component form, vectors are represented with respect to a coordinate system. Okay. And hence, basically, it is based on your knowledge of coordinate geometry, which you studied earlier, that we develop the system. Whereas what we did geometrically earlier, it was all, if you see the derivations and formula and all, it was based on your knowledge of triangles, okay, and your knowledge of simple geometry. Whether that is right angle triangles or trigonometry or isosceles triangles or whatever, Pythagoras theorem, trigonometry, various such things, but it was based on plane geometry. And now the next thing, our representation of vectors in component form is going to be based on our knowledge of coordinate system or coordinate geometry. Okay. So before we start the actual representation, there are a couple of important definitions. Okay. So now what we define for component system, okay, first of all we define base unit vectors, which is why we had paid attention to unit vectors earlier, or sometimes also called standard unit vectors. Are defined. So we define something called I cap. So if you've been reading ahead in your vector algebra book, you will see a lot of questions and explanations with I cap. So I cap is nothing but a unit vector. That means its magnitude is 1, but its direction is along what? Along the positive x-axis. So it's a unit vector along the positive x-axis. So the first step in this is actually we have to define our axis, because everything is with respect to our axis system. And similarly, the second unit vector that we define in two-dimensional system is given the symbol j cap. So this is just a matter of convention, that universally we understand the symbol used for the x unit vector or the positive x unit vector is I cap, and the symbol used for the positive y one is j cap. So this is the unit vector along positive y-axis. Okay. So this is the first definition, that for any component system, we have to define what is called our base unit vectors or our standard unit vectors. Okay, which is I cap along the positive x-axis and j cap along the positive y-axis. Right. Next, once we have defined the unit vectors, how do we represent a vector? Vector represented in component form becomes like this, that the vector will be written as some scalar quantity which we denote as ax multiplied by the unit vector I cap plus some scalar represented by the symbol ay multiplied by j cap. So this is how we will represent it. Where what are ax and ay? They are what we call the components of the vector A along the x-axis and the component of the vector B along the y-axis. So here, by definition, the components of the vector A along x and y-axis respectively. ये इसका definition हो जाता है. Okay? So ax and ay are scalars. Okay. They have sign. They can have negative sign also. Okay. So I'm just minimizing this for a moment, okay, and you will understand this. I have to switch to another whiteboard, so I'll have to make the diagram again. So no worries, we'll understand this whole thing once again. So see, what is happening is we are defining now. First of all, we are defining some coordinate frame. So we are defining a particular direction as our y-axis and a particular direction as our x-axis. And because it's a standard Cartesian system, so my x and y-axis have to be perpendicular to each other. So that's the only constraint I have. मुझे x और y axis ऐसे select करने कि they are perpendicular to each other. It doesn't have to be that x has to be towards east and y has to be towards north. It can be any convention. Now in this system, when I'm defining some particular vector, rather than drawing an arrow like this of it, I will define it in a different manner. I will write it in terms of what is called components. Okay, and I'll explain to you what the components are in this moment. Okay, so if I'm representing the vector A in component form now, or the component notation. So the first thing is, after defining the xy system, I will define what is called the components of the vectors. I will define the unit vectors. Okay, so the base unit vectors. The base unit vectors here are I cap and j cap. Where in the same diagram, if I were to draw I cap, how it would look like? It would look like a vector of magnitude unity along the x-axis. Remember, vectors are movable objects as long as I don't change their magnitude and direction. So I cap would be a vector like this, whose magnitude is unity. Okay, and similarly, j cap would be a vector pointing along the positive y-axis. So it doesn't matter where I draw it from, but the important thing is its direction is pointing along the positive y-axis and its magnitude is unity. So that is how I define this. Okay. Now, according to the component algebra, what I can do is when I represent the vector E in component form. Okay. So representing the vector E in component form, what happens is it is written as some scalar quantity Ax multiplied by the unit vector I cap plus some scalar quantity Ey multiplied by the unit vector j cap. This is how we write. This is what is called the representation of vector E in component form. This is how we write it. Okay, where Ax and Ay, they are called the x component or component of vector E along the x-axis, and Ay is called the y component of the vector E. Okay, so first just make a quick note of this thing over here, then I'll explain more. Okay. So in component form, remember the system of vectors. Okay, the vector is represented in relation to or with respect to a coordinate frame. This is the thing. So you represent the vector A with relation to this system of x and y axis. And the moment you've defined your system of x and y axis, the next important thing is the base unit vectors, or what we also call the standard unit vectors, which is nothing but I cap and j cap. So what is I cap? It is a unit vector along the positive x direction. Along the direction in which your positive x axis is pointing. And similarly, j cap is the unit vector along your positive y direction. Like I've drawn the two red colored unit vectors. They are both of magnitude 1, but they're perpendicular to each other. One is, so they are standard. No matter what your vector E is, no matter what your other vectors B are and all that, the vector E, the unit vectors I cap and j cap, they have a fixed meaning, and that is nothing but they are pointing along the positive x axis and the positive y axis respectively. No, to answer your question, some of you, when we use component algebra, the answers or the result that we get for any operation will not vary with respect to geometry. It will be the same. Okay, but it's just a different way of solving. And I'm coming to that. But first, let us understand what these components are. Let's understand their formula and all that. Okay. So far, I've just given you this thing. I've just given you the formula of a vector, or the way of writing the vector, or the representation of the vector in component form. Where I'm telling you कि ये representation में ax क्या होता है, by definition it is the x component, ay क्या होता है, it is by definition the y component. Now next we'll see what exactly is the meaning of that. What do we mean by x component? What do we mean by y component? Like that. Okay. So first just make sure you noted down this part, then I'll come back to this. Okay. And of course here we also understand that ax and ay are scalar quantities. Okay. And have positive or negative sign. Okay. That's another thing that we understand. That ax and ay are not vectors. A vector is the one which is the vector. Okay. I cap is a vector, j cap is a vector, but the quantity ax is just a scalar quantity. The quantity ay similarly is just a scalar quantity. Okay, so hope this point is clear up to this. Now let us go back to our diagram and let us understand what exactly we mean by ax and ay. Okay. What is the physical meaning of ax and ay? So for that, let's take a fresh diagram. Let's understand here that Now let's say initially I'm just worried in the first quadrant, so I'm not getting so much into 4 quadrants, but eventually we'll see 4 quadrants also. So this is x and this is y axis, and the vector E is like this now. So in geometrical form, this is the vector E. So in geometrical form, this arrow represents the vector A, where the length of the arrow is basically what? The magnitude of the vector, and the direction is the line of action. So the vector's line of action is this line. Okay. Now, इसमें हम components कैसे draw करेंगे, or what do we mean by the term component? So let's understand that next. Okay. So for that, if we drop a perpendicular like this onto the x-axis, and we drop 2 perpendiculars like this onto the y-axis. Okay. So if we do this, and this is, remember, just to talk about components. So they are just guidelines. So they are no actual lines. So now you can see that this one, it is throwing some kind of a shadow on the x-axis, and is throwing some kind of a shadow on the y-axis. So this shadow is nothing but Ex, and this shadow is nothing but Ey, and that is why we are representing the vector E as the sum of this shadow plus this shadow. So this shadow has magnitude Ax but direction along I cap, and the projection on the component along the y-axis, it is Ay in magnitude, but its direction is along what? The y-axis. So the vector E is in fact the sum of this in this. Okay. So first make a note of this diagram, and then through another diagram I'll explain how we are able to write this formula that the vector E is actually the sum of Ax I cap plus Ay j cap. But first of all, let's understand इसमें Ax क्या है? Ax is this thing. Ax is this component or this projection. So component and projection are actually interchangeable. They mean one and the same. So you can see that Ax is the projection or the component of the vector A along the x-axis. So the word projection is also usable over here, of the vector A along x-axis. And similarly, Ay is the component of projection along the y-axis. Okay. So naturally you can see that for my vector A, which is inclined at theta equal to an acute angle with respect to x-axis, Ax and Ay are positive. But if it were inclined at an obtuse angle, then Ax would become negative, Ay would become positive. If it were in third quadrant, then both Ax and Ay would become negative. If it were in fourth quadrant, then Ax would be positive, whereas Ay would be negative. So that is how this is actually linked to the concept of projections and the ASTC rule that we've just studied about. Okay, so understood, given a vector A, how we are obtaining the projections Ax and Ay or the components Ax and Ay from the vector's base and from the vector's head, right? So this particular vector's base is over here and this particular vector's head is over here. So from the head and the base, what we are doing is we are dropping two perpendiculars. We are dropping a perpendicular from the head onto the x-axis, a perpendicular from the base onto the x-axis. So the projection it is cutting, that is nothing but the component. Similarly, from the base, we are dropping a perpendicular on the y-axis. From the head, we are dropping a perpendicular on the y-axis. So the shadow or the projection, or in other words, the component is dropping. That is what we are labeling as Ay. Right, people? So hope this is clear. Okay, so now I'm next moving on to the relationship between the magnitude of the vector and the components, and also the angle. Okay. So the relation between the components, okay, and E, or more properly magnitude of the vector, and theta, that is the angle with respect to the x-axis. So let us understand this. Okay. So on the one hand, we have the relationship between what we call the components, and on the other hand, we have these things, which is basically to do with the geometry. That geometrically, how the vector is looking, what is its angle with respect to the x-axis, and what is the magnitude of the vector. So how we interrelate these two things, let's understand that next. Okay. So that's very easy, and you would have guessed by now actually how that's working out. So it's just trigonometry and nothing else. Because the components of the vector and the vector itself, as you can see, they form a right angle triangle. So again, it doesn't matter whether I draw the vector A from the origin. I can draw it from anywhere, it doesn't matter. But if I just now draw a vector like this and draw another vector like this, so you can see that this is nothing but Ax. So this vector is Ax I cap. Because remember, Ax is a magnitude and you multiplied it with a unit vector. So it's become a vector. No? So this Ax I cap on its own has become a vector of magnitude how much? Ax. But pointing in which direction? Along the positive x direction. Similarly, if you drop this perpendicular here from this point, and if you drop this perpendicular from this point, you can see that this length here is nothing but Ay. Okay. So over here, this is nothing but a vector of magnitude how much? Ay. But direction along which direction? The upward direction. So that unit vector is j cap. So it's a vector of magnitude Ay, because this is unit vector, but direction which? Pointing upwards along the y-axis. So that is why we can say, now just apply your knowledge of vector algebra and you'll see that this vector Ax I cap, which is this one, this vector Ax I cap, which is this one, plus this vector Ay j cap, a perpendicular vector, which is this one. What is the resultant of these two? It is nothing but this vector. And this vector is what we have labeled in the first place as the vector E. So that is the logic of saying that the vector E is actually the sum of Ax I cap plus Ay j cap. And thereby, what do we mean by Ax? It is nothing but the projection on the x-axis. And what do we mean by Ay? It is nothing but the projection on the y-axis. So logically in this diagram, you will understand why we will express the vector A as what? We'll express it as the sum of that base wala vector along the horizontal plus that perpendicular wala vector, which looks like it's along the vertical in my diagram. So that is the logic of this. This is a vector of magnitude Ax along the positive x direction. This is a vector of magnitude Ay along the positive y direction. And logically, their sum or their resultant should be which vector? It should be the vector A. So that is why the vector A is represented in this manner. Okay, people, so hope this is clear to you now. Now, this makes it clear what is components. Now, what is the meaning of components? So, what is the value of I cap? Beta, I cap, see, any vector written with a cap instead of an arrow, it means it's a unit vector. So, उसका magnitude क्या है? Unity. उसका direction क्या है? Along the x-axis. So, that is the vector I cap. No. If you mean by value magnitude, then its magnitude is 1. But what is it as a vector? It has two things. It has a magnitude and it has a direction. So I cap का magnitude कितना है? 1 है. उसका direction क्या है? Positive x के along है. J cap का magnitude कितना है? Its magnitude is unity. But what about the direction of J cap? It's upward. So J cap would look like a vector like this of magnitude unity, and I cap would look like a vector like this of magnitude unity. Okay. So next, when I work this out with some examples, this will become even more clear. Now, what is the relationship between these two? So if this angle is theta, this is the angle that the vector E is making with respect to the x-axis. Because if you see the direction of vector E, it is at some kind of angle with respect to the x-axis. So that is this theta. And this is the line of action. So ये जहाँ पर भी x-axis को cut कर रहा है ये line of action, that angle theta is the angle that the vector A is making with respect to the x-axis. And the magnitude of this line or the vector is nothing but E. So now you see this is a right angle triangle. So what is the relationship between these? Your relationship is that Ex is equal to A cos theta. So this is the definition, Ax I cap plus Ay j cap. But usme what is the relationship of Ax with respect to the geometry? That is the magnitude of the vector A and the angle it makes with the x-axis. This is the relationship. It is A cos theta. And what is the relationship of Ay? It is nothing but A sin theta. So this is one way to express what we had set out to do. I wanted to find the relationship between the two things which are important of the vector. One is the components. I wanted to find out the relation of the components with the geometry. What is the geometry? It is the length of the line and it is the angle. So wo A or theta versus Ax or Ay mein kya relationship hai? The answer to that is below here. This is the relationship. Okay, so just make a quick note of this and understand this. So that is what we accomplished over. How the vector A is Ax I cap plus Ay j cap, Devansh, to answer your question, is just think of vector addition. So you have one vector which is along the x-axis and of magnitude Ax. So it's like this. This is your vector Ax I cap, and you have another vector which its magnitude is Ay, but its direction is along which axis? The y-axis. So now what is the sum of these two vectors going to look like? It's going to look like this one. Now I've just drawn the Ax I cap over here. Then to its head I've added the Ay j cap. So the resultant of the two, or the sum of the two, is nothing but this. The upper part, but is not important just now. I just repeated that line over here. The relationship of components Ax and Ay with respect to this. So everything you need at the moment just now is there in the diagram. Okay. So take your time, make sure that this thing is clear over here. No, it's not a 2 theta. This theta is the same as this theta. Okay. This theta that the vector A is making with respect to this red colored line, which is nothing but Ax I cap. That is the same angle that the direction of the vector A is making with respect to the x-axis. Okay. Yeah, we could have found by formula, means this is the formula that we wanted to find. The relationship between Ax, Ay and theta. This is what we wanted to find. So that's where the formula comes in. Okay. Now the inverse of this formula is also that, just like we can say Ax and Ay are A cos theta and A sin theta, we can also say that the magnitude of the vector A is square root of Ax square plus Ay square, and tan theta is equal to Ay by Ax. So whatever formula this we have written, this is like an inversion of that. In the above formula, what is happening? If we know Ax and Ay, if we know magnitude of A and if we know the angle theta, then we can find the components Ax and Ay. And the below formula is the other way around. If we know the components Ax and Ay, we can find the magnitude and we can find the direction. Alright. So take a quick note of this and let's start applying this with some examples and we'll understand this better. Alright, so let's do a quick example now. Find Ax and Ay, that is the components of vector A given this information. Now the information I am giving you is in geometrical form. This is my x and y axis. And let us say I have drawn the vector A over here. So the vector A, it has a length of, let us say, 50, and this angle here is, let us say, 53 degrees. Okay, so let's say this is the first part. Just try this out, and I'll be giving you some more also. Okay, so let's start with this. Let's try out with these three questions. Okay, let's express the vector in component form and find Ax and Ay. So find Ax and Ay and express the vector E in component form. Yes, very good. Viraj and Kevin, both of you got it correct. Sanya, you are also right. Tarisha, the values of cos and sine 53 are respectively 3 by 5 and 4 by 5. Okay, 53 degrees is there in the 3, 4, 5 triangle. So you can figure it out from that. Yes, very good, Kevin. Aditya, in the third case, you'll notice that AX should be negative because it's making an obtuse angle. No? So its X component will become negative because cos theta is negative when the angle is obtuse. Okay, so let us quickly just go through each of these. So the first one will now look something like this. This is the vector A. Okay, so magnitude 50. And with respect to my, now see, just to add clarity to this, I can move the vector A to the origin. It makes no difference to the vector A. You're understanding my point here. So even though in the diagram I have not drawn the vector A from the origin. Okay. So this is how I've drawn that. But in this diagram now, as I've discussed earlier with you, if I just pick up this vector and without changing anything, I move it around somewhere else, it makes no difference to the vector. So this is still the same vector. There's no difference between this vector. There's still the vector A only. Just because I shifted it from here to here, it makes no difference to it. As long as I don't change the length of the line and nor I change this angle. So this angle is still 53. So this vector is the same as this vector which we drawn. Okay, so that becomes a convenient way of tackling a problem like this. That first you imagine you've drawn the vector from the origin. Okay, so you can see that this angle is 53 degrees. Okay. Now in this one, you drop the perpendiculars and you will understand what the components are. So this component is your X component and this component is your Y component. In other words, this perpendicular and this perpendicular. So this is your EX and with proper direction it is EX I cap as a vector and this is your EY cap. So EX is E cos theta. So that is 50 cos 53 degrees and that is nothing but 50 into 3 by 5. So it is 30. Similarly, your EY will become E sin theta. So 50 sin 53 degrees. So 50 into 4 by 5. So that will become 40. So the components are 30 and 40. And when I express the vector in component form, the vector A will be written as therefore AX, which is 30 times I cap plus AY, which is 40 times. So this becomes the proper description of that. Just take a quick look at this and then try to repeat these steps for all the other two parts. Yes, Yashmit, very good. Okay, so this was the first part. Now let's move on to the second part. Now the second part is extremely easy because that vector is actually perpendicular to the axis. So it was very simple. With respect to a system of x and y, the second part the vector A itself was like this. So you can see that it had a magnitude of 12 or whatever that was, and this angle was 90 degrees. Okay. So AX, which is A cos 90 degrees over here, is 0. Okay. And AY, which is A sin 90 degrees, is just A itself, which is 12. So the vector A is becoming 12 j cap. I hope I had taken the value 12 only, I don't remember, but whatever the value is, that number, it will be just that many times j cap. So now the slightly tricky part is the third part, which I am coming to, but first, let's go through this and let me quickly verify if one is correct. Yeah, 12. So this is the solution to the second part. So Palak, you are correct. Sanya, in the third part, yes, you got it correct now. Aditya, if you're referring to the third part, you again just either go by the formula or just use the diagram and you'll understand. So, for example, if you're using the formula, I've told you how to calculate cos 120. It's in second quadrant, na? So, second quadrant में हम angle को किससे convert करते हैं? 180 minus theta से convert करते हैं. So, the formula for cos was cos theta is minus cos 180 minus theta, and sin theta was sine of 180 minus theta, because sine is positive in second quadrant whereas cos is negative. Similarly, today we learned in third quadrant, the angle is written in terms of theta minus 180. In second quadrant, it is written as 180 minus theta. In third, it's written in terms of theta minus 180. And finally, in fourth, it is written as 360 minus theta. Yeah, so going up to the third part, I'm just putting it up for you. This was the. So you just redraw the diagram where you drag this to the origin. It makes no difference. So that angle is 120. So you can see that the component on the x side will be a negative component, whereas the component on the y side will be a positive. So many of you got the third one correct. Okay, the x component in the third case will come with a minus sign, and it will be minus of 5 root 3. Is it? Or minus 5, sir. Minus 5. And the y component will come as positive and plus of 5 root 3. Okay, people, so I'm just going with the detailed working of the last part now, the third part. So I had a vector of magnitude 10 units, okay, but it was inclined at an angle of 120 degrees with respect to my x-axis. So now, as I told you, we can shift the vector to this origin point just to make it more convenient for us. So that doesn't make any difference to the vector as long as we don't shuffle anything in the vector. Like we have not stretched it or compressed it. So we have kept it 10 unit and we have not adjusted its direction. So this angle is still 120. Okay. So now you can see that the moment you drop the perpendicular on the x-axis, the component that you will get or the projection is falling on which side? Is falling on the negative side, and the projection on the y side will fall on the positive side. Okay. This is my x component. This is my y component. So from the diagram sign convention, you can understand that Ax has to be a negative quantity. And from the diagrams, this thing you can understand this has to be a positive, which is consistent with your trigonometry, because cos theta is negative in the second quadrant and sin theta is positive in the second quadrant. So that's where I told you that there's a very good interrelation between trigonometry in 4 quadrants and vector projections or vector algebra. And in fact, the best way to understand trigonometry in 4 quadrants is from vector diagrams, because that is what it was designed for in the first place. The whole idea came from vector directions. Otherwise, why would you want to define cos 120? In terms of right angle triangle, cos 120 doesn't make any sense. So that was the whole point. Okay, so here Ax, which is E cos theta by definition, it is becoming 10 into cos 120. Now remember, cos 120 will be written as cos of 180 minus 120. Sorry, minus of cos 180 minus 120. Okay. So this is where this comes in, that cos theta is minus of cos 180 degrees minus theta. This is for my quadrant 2. So further, cos 120 degrees will become minus cos 60. That is minus half. So that is why your Ax will become minus 5. And similarly, Ay, which is A sin theta, will be 10 sin 120. And now for sin, we will use the formula. Sin theta is positive of sin 180 minus theta for second quadrant. So using this formula, this becomes 10 sin 60. So that is 10 into root 3 by 2 or 5 root 3. So positive of 5 root 3 is the y component, whereas minus of 5 is the x component. So my vector A in component form now becomes like this. So you'll see this equation is in principle giving you the same information that my diagram had given. Okay, people. So this is the complete description of this particular question. So we will be doing lots of practice of this, including a lot of vectors in second, third, and fourth quadrant. So by the time we are done with component algebra and component notation of vectors, you will absolutely become very thorough with trigonometry in 4 quadrants. Yes, half can be written as 0.5, or that component just becomes 10 into minus half, so it becomes minus 5. That's the idea. You substitute cos theta as minus half in the above equation. So E cos theta becomes 10 into minus half. So that's how it's becoming minus 5. Don't forget, in the component there's 10 also. No? It's not just cos theta, it is A cos theta. You have to multiply 10 with minus half. Yes, you can always take the values in decimals. I mean, there's no problem with that. Okay. Yeah, application we're going to just understand. Okay. So we'll see very soon here that by using component method, we have a very easy way of doing addition, subtraction, of not only two vectors but now multiple vectors. Whereas अभी तक हमने geometry से क्या सीखा था? Only how to add two vectors. I just missed the point. What was that? So vector calculations are mostly related. In a sense they are, because your component notation comes from trigonometry. Or if you do geometrical method also, mostly you are dealing with trigonometry only. So trigonometry and vectors are very interrelated. Yes, you can definitely say that. No doubt about that. Okay. So now you understood this. Okay. Now next we will do a reverse type of question. Okay. So in this question, what we did, I had drawn three vectors for you. Drawn means I have given you their magnitudes and drawn the angle for you, and I asked you to find the components. Now I'll do the reverse of that. So I'll use. So next we'll see, we'll use this relation that if I know the vector A in terms of its components, Ax I cap plus Ayj cap. So I know Ax and Ay. Okay. Then from this, how I can find the magnitude of the vector and the direction. And what I mean by direction is the angle it makes with the x-axis. Okay. So let us see how we will accomplish this kind of thing. Okay, next. So let's understand that with a question. So given the vector E in component form, we want to find the magnitude of the vector E and theta, that is its angle with respect to the positive x-axis. We want to find it. So let's do a question related to this. So the vector E is now given as 5 I cap plus 5 root 3 j cap. Actually, this is not question mark. What we have to find is what I've written above, the magnitude and the direction. But the given quantity is what this. The second case, let's say I'm giving the vector E as 12 I cap minus 16 j cap. In the third case, I'm giving the vector E as minus 2 I cap plus 2 j cap. Okay. So just try this question out, people. So with these type of questions, first we'll get very comfortable with component algebra. You know, how to write a vector in component form, how to represent, and how to understand the relation between the geometry of the vector and the components which are given. Once you've done that, then we'll be in a position to very easily do summation of vectors, difference of vectors using components. And of course, eventually we will also be moving to three-dimensional components. So far we are seeing only in the XY plane, or what is called two-dimensional component algebra. Eventually we'll be moving on to three-dimensional components where there's X, Y, and along with that there's the mutually perpendicular Z axis also. So things get both very interesting as well as a little bit complicated at that stage when we come to 3D. But a lot of interesting things which you might have been wondering about 3D geometry till date, ये कैसे calculate करते हैं, वो angle कैसे निकालते हैं, things like that, you'll be able to solve by using three-dimensional component algebra. Good. So I'm getting the answers. Let me check. But Aditya, what I want is the direction in terms of angle. Okay. Someone just check your calculations again. Okay, so Aditya, you're giving me the direction in terms of unit vector, which is, it's okay. Actually, it's a more advanced way of giving the direction. Okay. We will be discussing direction by unit vector method later also. But here I want actually theta. I actually want the angle. Yes. Dhruv, correct. Yes, Archit, your answers are also correct. Kevin, you are also correct. Okay. Only now, Kevin, try to give me the angle in degrees. Okay, you're given in tan inverse form, that's correct. Your answer is correct that way, it's acceptable. But I also want the value in degrees. So use 3, 4, 5 triangle. Okay, remember for 3, 4, 5 triangle, the angles are 37 and 53. Yes, Amay, the formula you should use is the one we just discussed in the section before, that how to find mod A and theta when I know Ax and Ay. So the answer is A, or the magnitude of the vector becomes square root of Ax square plus Ay square. No, because if you draw the components along with the vector, you get a right angle triangle. So right angle triangles mein kya ho raha hai? Ax and Ay are the perpendicular sides, and the actual magnitude of the vector A is nothing but the hypotenuse. So you use that formula for the magnitude, and for the direction you use the formula that tan theta is equal to Ay by Ax. Okay, so the answers I'm getting in by and large are correct now, but for the benefit of everybody, I'll just quickly work this out. So the first part, I've taken the vector E as I think 5 I cap plus 5 root 3 G cap. So you can see that the X component, which you can also think as the magnitude into cos theta, that is equal to plus 5. Okay, so that immediately tells you two things, that the vector can either be in first quadrant or fourth quadrant, because that is where cos theta is positive. Second quadrant में नहीं हो सकता है, third quadrant में नहीं हो सकता है, because then they should have been negative. Now it's also telling you that the y component, which is denoted by a sine theta, is also positive. So that means which quadrant it has to be? It has to be in the first quadrant. It is plus of 5 root 3. Okay. So now just square and add the equation 1 and 2. The next step is if we square and add, we'll get what? We'll get a square cos square theta plus a square sine square theta. We'll get a square is basically equal to ax square plus ay square. So that in this case is 5 square plus 3 times 5 square. So you can see that e square is square root of 25 plus 75, or e square is 25 plus 75. So the magnitude of the vector e is becoming 10. Now simply square root of ax square plus ay square. From here only, we got that formula that magnitude of a is root of ax square plus ay square. So we're just making use of that. Okay. Now the other thing is, you can see that tan theta is equal to ey by ax, okay, which is equal to, in this case, how much? It is root 3. Okay, so it is positive. Okay, and in first quadrant, how do we know in first quadrant? Because ax and ay are both positive. That's why we know that it's in first quadrant. So first quadrant में ऐसा कौन सा angle है जिसके लिए tan theta plus root 3 है, that is 60 degrees. So you can see theta is equal to 60 degrees. Okay. So in fact your vector is looking like this. We have magnitude 10, but the angle with the x-axis would be 60 degrees, which is why your x component is 5 and your y component is 5 root 3. Yes, that's the complete story of the vector. You could have, of course, just found out the answers by using the formula. That magnitude of A is root of ax square plus ay square, this formula here. And then this formula here, that tan theta is ay by x. But where those formula actually come from and what is the logic of it? That is. Yeah, Sarvesh, to answer your question, actually, there is no such thing as, absolute that we have to take with respect to ground. It is like in whatever real life problem we are solving, we will select our axis according to our convenience. Understanding your point? So if it is convenient for us to take x-axis as horizontal and y-axis as vertical, we'll do that. If it is convenient for us to take x-axis along an inclined plane, because the body is actually sliding up an inclined plane or sliding down an inclined plane, or a barrel is rolling down an inclined plane, then we can always take x-axis along an inclined plane also. There's no problem with that. So we always select our coordinate frame or draw our axis according to our convenience. Yes, Viraj, that is correct what you're saying. Yes, so Sarvesh, I hope that answers your question about the real theta. Okay. Guys, I know we are exceeding time a little bit, but we had some connectivity issues on my end, so we just be another 10 minutes by the time we finish. By now you might be used to it also that I generally exceed my time, but so let's come to the second vector now. It was 12 I cap minus 16 j cap. Okay. Now this is where we have to be very careful and understand कि क्या हो रहा है. My vector, second case, it is 12 I cap but minus 16 j cap. So it's actually lying in which quadrant? The fourth quadrant, you can see, because the y component is negative, the x component is positive. Ex is plus 12, but Ey is how much? It is minus 16. So when you draw your axis system, you immediately realize what I'm talking about. With respect to the system of axis, you can see that this is a vector which is having a positive x component and a negative y component x. This is minus 16 j cap and this is plus 12 I cap. So the vector E is such that its head must be lying here. As you can see, the vector E is like this, and if we write the angle properly, it should be this whole angle. This angle should be theta. As you can see, it's in the fourth quadrant, theta. Okay. So just solving for this now. So you can see that magnitude of A will come out to be 20. Okay. Tan theta will come out to be Ey by Ax, which is in this case minus 4 by 3. But in which quadrant? In quadrant 4. Okay. So we'll have to use the formula of quadrant 4. So I'm just coming to that. How you'll use that formula to find the angle theta. And Sarvesh, to answer your question, if theta is 0, you know cos 0 is 1 and sin 0 is 0. So if the angle it's making with the x-axis is 0, then that vector only has an x component. It does not have a y component. And if the magnitude of a vector is 0, Amay, to answer your question, then it's a null vector. So it does not have any components. Its magnitude is only 0. And to answer your question, can it be in the second quadrant? No, because you can see here that the vector A given has a negative y component and a positive x component. So it cannot be in the second quadrant. It is configured in such a way that it has to be in the fourth quadrant. Second quadrant होने के लिए क्या होना चाहिए था? X component should have been negative and y component should have been positive. So anyway, the angle you will get will actually be 360 minus 53. Okay, so that is 307 degrees. Okay, so just let me explain how we'll get this here. Now I'm solving this part. So tan theta is equal to minus 4 by 3, and theta is in quadrant 4. So what was the formula of quadrant 4? That tan theta was minus tan of 360 minus theta. Okay. So that is minus 4 by 3. So that means this thing, tan 360 minus theta is 4 by 3, which means 360 minus theta itself is 53 degrees, which means theta is 307 degrees. Or there's a simpler way of expressing this, or we can say that theta is minus 53 degrees. Anti-clockwise of this is the same thing as clockwise of 53. So that is the concept that I'm doing. So an angle of 307 degrees can also be expressed as minus of 53 degrees. That's also an acceptable way of writing the answer. But the more proper way of writing the answer is actually with the positive sign, the anti-clockwise angle of 307 degrees. Okay guys, so hope this is clear. Okay people, so this one is clear, I hope. Okay, now I'll quickly move on to this one. Okay. So this, as you would have guessed, is now lying in which quadrant? Second quadrant, because the x component is negative and the y component is positive. So I'll just make a quick review of this one before. So vector E is minus 2i cap plus 2j. So you can see that Ex is minus 2, Ey is plus 2. So that is telling you what? That cos theta is negative, sin theta is positive. So theta is in which quadrant? Theta is lying in quadrant 2. Okay, so that's what. Okay. Also, you can just draw the vector. So anyway, just if you use formula, magnitude of A is just becoming Ax, that is minus of 2 square plus Ay square plus square root. So it is becoming 2 root 2. That is the magnitude of the vector. And if I use this now, you can see that tan theta is equal to Ay by Ax, which will come out to be minus 1. In which quadrant? In second quadrant. So for second quadrant, the formula we'll use is that tan theta is minus of tan 180 minus theta is minus 1. So you will have to get used to the formula. Okay, second quadrant how we express it, fourth quadrant how we express it. You will have to get used to this, and this will take a bit of time. Okay, so I'll give you an exercise after today's lecture, which will just focus on that thing only. But once you get comfortable with it, you'll see it's very easy. So this angle 180 minus theta is in fact becoming 45 degrees, which means, as many of you have been pointing out correctly, theta is 135 degrees. This is theta and this is mod. The same information you can also extract by just drawing the vector, okay, and figuring out from the trigonometry of the triangle, the angle and everything. Okay, so alternately, if you just draw this vector, you can see it will come out to be like this. A vector like this. So you can see, just draw this, it becomes very clear that this angle is 135. Samar, to answer your question, you can use tan in all the quadrants. It's not that you have to use in second and fourth, or in first you will use sine. It's all one and the same thing. The x component ax is a cos theta. The y component ay is a sine theta. So y divided by x is what? Tan theta. Similarly, you could have used x divided by y is cot theta. But why I am using tan is because I have defined the formula for sine, cos and tan. So I am not preferring cot. I don't want to confuse us with too many formulae. Okay, but Achha, I have understood. You mean in terms of sine, because in third quadrant tan sine is positive. Yes, you can do that if you find that more convenient. But eventually you'll get used to the signs also. Okay. So this is about the components. Okay. Now, just one last thing before we conclude today's lecture, we'll see, which is actually very simple. That how to do addition or subtraction of two vectors using components. Okay. So addition or for that matter subtraction. So this is our first official study of subtraction of two vectors by component method. Okay, so if I have two vectors given to me in component form, some component along the x-axis plus some component along the y-axis, and same for B. Okay. So if we are adding the two vectors, for example, just think that you are adding this quantity with this left hand side of both the equations you are adding. So right hand sides also get added. So what we mean by adding the right hand sides is that you just take I cap component common and you have ax plus bx, and you take j cap common and you take ay plus by. Okay, so it becomes like this. So the vector a plus b, now you just do that same operation, the addition on the right hand side, but when you do the addition on the right hand side, you can see I cap you can take common, so it just becomes ax plus bx into I cap, and similarly you can take j cap common, so it becomes ay plus by into j cap. Similarly, if you're calculating the difference of the two vectors, for example, so you just do a minus b on the left hand side, and you do a minus, minus of the two quantities on the right hand side. So again, when you take your I cap common, it will just become ax minus bx I cap plus ay minus by. So this is how we do the addition or subtraction. And we can, in fact, in the next lecture, we'll see how we can extend this to more than two vectors. So we have a plus b plus c plus d plus any number of vectors. Their sum will become the sum of the x components, the whole thing into common I cap, plus the summation of all the y components, the whole thing into j cap. Okay. Similarly, if we are doing a minus b, it will become ax minus bx into I cap plus ay minus by into j cap. So even if we have the question in geometrical form, actually, the diagram is given to us with arrows and all that, we always have the option of converting the geometrical form into component form using the formula we've learned today. You've learned how to, how to convert from magnitude and angle into components ax and ay using the formula ax is equal to a cos theta and ay is equal to a sin theta, and then using this very simple and easy step to add, or using this very simple and easy step to subtract. Alright, so we make a quick note of this formula, and then we'll look at a quick application, and another minute or so will be done. Alright, so I think this should be pretty self-explanatory. Now let's look at a quick question. So for example, suppose what we are given is in geometrical form. Vector E is like this, and its magnitude is, let us say, something, it is 10, and vector B is, let us say, like this, and its magnitude is 5 root 2. And also, this angle is given to me as 45 degrees. And I have asked you to find the magnitude of the resultant, where resultant is E plus B. So one option is you can draw a triangle or apply the triangle law. So you can see that the actual angle between the vector A and B is not 45, it is this angle, it's the exterior angle, it's 135. And you can use the formula and all that. The other option that we have based on what we've learned today is we can define this as our x-axis, we can define this as our y-axis, and first express the vectors A and B in what? Component form, and then just use the formula. So that, as it turns out, might be an easier method also. Okay. So let us attempt this question by using that method. So what we'll do here is steps. We'll first express vector A and B in component form, and then calculate the resultant equal to A plus B. So let us do these steps. Okay. Now for component form, the first thing is you need to define your axis. तो यहाँ पे दो ही वेक्टर्स हैं, तो एक्सेस डिफाइन करने के लिए आसान क्या होगा, दैट एक वेक्टर के डायरेक्शन को we'll take as our x-axis. So we are taking the vectors A's direction as our x-axis. So doing that, now first tell me what are the components. Yes, Samarth, your answer is correct. Kevin, your answer is correct in component form. So now magnitude of R, you just take mod of that. Okay. So my vector E in component form, when you write, it should become like this. It should just become 10 I cap. Okay. Now my vector B is a little more complicated, so I'm showing it on this side. Okay, so for vector B, उसका magnitude है 5√2. Okay, but with respect to x-axis, उसका direction क्या है? It is in fact the proper angle. If you see, is in fact this. So it is 135 degrees with the x-axis. So the vector B will actually become minus 5 I cap plus 5. Is this step clear to all of you people? Yes, 5√2 is the correct answer. Yes, you got it correct. So is the second step for the vector B written in component form clear? Okay. Because see, ये जो component है, when we drop this perpendicular, this is 5 and this one is also 5, but this is falling in which direction? It's falling along the negative x direction. So the component is what type? It is negative. So it's minus 5 times I cap. And this is positive. So it's plus 5j cap. So now you can see that the resultant very simply will just become the summation of these two. So you take your I cap common and add the two. And you take your j cap common and add the two. So it is plus 10 minus 5 I cap plus 0 for A and 5 for B j cap. So it is 5 I cap plus 5j. That is becoming the resultant as a vector. So further I had asked you for the magnitude of the resultant. So that we'll just express by using the formula. It is x component square plus y component square. So it is 5√2. So one of the first things you should do when you are revising this is, when you are revising this, also do this question by the geometrical method using the statement of the triangle law, the formula of the triangle law. Yeah, so just to explain what I've done here is, see, vector x y axis के हिसाब से मेरा vector A कैसा था? My vector A was like this. It was along the x axis and its magnitude was 10. So that's how this became. But what about the vector B? My vector B was like this. This was the vector B at an angle of 135, okay, like this, and magnitude 5√2. So I wrote vector B now in component form. Now resultant is what? The resultant is sum of A plus B. So when I'm doing sum of A plus B, see, in these two equations, I'm just adding the left hand side, so that's the resultant. So on the right hand side also I should add. So when you add these quantities, take I cap common. So what you're left with? 10 plus of minus 5. So that is 10 minus 5, that's 5. And for j cap you take common. So this has no j cap component. So it's 0 plus this has 5. So it's 5. So that is how the resultant is becoming plus 5 I cap plus 5 j cap. And that magnitude is nothing but 5√2. Alright, so hope this should make it clear for you. Okay. And do a revision of the theory of the lecture notes, as well as if you require the video and all that also, and you should be able to follow. Plus I will be giving you a worksheet this time which will be exclusively mostly about the component algebra of vectors. So that's it for today's lecture, and thanks for the patience in staying over time. Okay, but we have accomplished what I wanted in this lecture, so that's a good thing. Next lecture I will start with some problem solving, which will include some questions from worksheet 2, as well as today's worksheet, which I'm going to give is worksheet 3, plus any other doubts that you might have. Okay, I've also asked you to solve some questions from the booklet, so I'll be discussing some of those. So next lecture will be more like a problem solving lecture. We will learn a couple of things in theory ahead, but that will be the secondary thing. The first thing we'll do is some doubt questions and some other questions I want to discuss, which are from your booklet. Okay, that's it for today, guys. Bye and take care and stay safe until next week.